Morning. Today we look at the inverse of a matrix or inverse matrices using Gauss elimination. So we find the inverses of square matrices, but the inverse of a square matrix only exists if the determinant of that matrix is not equal to 0. So we say that the inverse of a square matrix exists if and only if the determinant of the matrix is not 0. So let's say we're given A. This is a square matrix. So a square matrix, that means it has the same number of rows as columns. Then we can check whether it has an inverse or not by looking for this A's determinant. And if this is not equal to 0, so it doesn't matter whether it's positive or negative, as long as it is not equal to 0, then A inverse exists. So we can look at an example of how we will actually work this out. So we are given a matrix A. This is -1, 1, 2, 3, -1, 1, -1, 3, 4. And we want to work out the inverse of this matrix. So first thing we have to do is check whether the determinant is non-zero. Then we can proceed to actually use Gauss elimination to work this out. So we'll work out the determinant. So the determinants did last semester, or it was a self-study topic for you. But with any matrix, what you do to work out the determinant is you pick a row or a column that you want to move along, and then you will use that row to work out the determinant. So let's say I pick the first row to work out my determinant. We'll say this is equal to, so I take this first number, this is -1, and then I multiply it by the determinant of the matrix that I have over here. So I remove, because -1 is in this row and that column, what is left is this matrix over here. So I find the determinant of this matrix, which is -4 minus 3. So I have -4 minus 3. Then I move on to the second element in the row, which is 1. Now all of these elements in the matrix have a sign. So there are signs. The first one, it's plus, minus, plus, minus, plus, minus, plus, minus, plus, like that. So this one here has a -1 associated with it. So I write -1, and then what I do is I remove this row and that column. Then I'm left with this matrix here. And its determinant is 3 times 4, which is 12, minus -1 times 1, so it's minus -1, which is plus 1, or just write minus -1, like that. Then with the 2, I do the same thing. The sign associated with the 2 is positive. So I have +2, and the matrix, if I remove the row that 2 is in and the column that 2 is in, I am left with this matrix over here. So I work out the determinant of this matrix that I have left. So 3 times 3, this is 9, and then 9 minus -1 times -1, which is just 9 minus 1. Okay, then all this I can just type in on my calculator. -1 times -4 minus 3 minus 1, 12 plus 1 plus 2, 9 minus 1. And this should give you a determinant of 10. And 10 is not equal to 0, and that means that the inverse exists. So remember, the inverse exists if and only if the determinant is not 0. So here we can say that the inverse exists. Okay, so now that we know that the inverse exists, we can proceed to actually work out what the inverse is. So the way we do that is we will draw an augmented matrix like this. So the first part will be your A. So A, which was -1, 1, 2. And then we have 3, -1, 1, -1, 3, 4. And then on the other side, we put an identity matrix. So we have 1, 0, 0, 0, 1, 0, 0, 0, 1, like that. So the goal here, or what it is we are trying to do, is we want to make this side over here the identity matrix. So just like we did with solving the system of linear equations, except this time we have a bigger matrix. But the procedures we do, adding rows, subtracting rows, multiplying or dividing rows by constants, we still do all of that. Okay, so first thing we can do is we can say divide this first row by -1. So we are going to divide this by -1. So remember, write down whatever it is you are doing so that anybody who's reading your work can actually follow and understand how you got to the next matrix. And then this one here, I will say this is row 2 plus 3 times row 1. Okay, that's 3 times row 1. So that's before I divide by -1. So I will multiply this row by 3. Then here you can see I'll have -3. And then when I add it to this 3, I will have 0 here. Then here I have -1, -1. To make this 0, I just subtract. I just say row 3 minus row 1. So here, say row 3 minus row 1. Okay, then I write down what I get. So I say the first row, I will divide it by -1. So I have 1, -1, -2. Then -1, 0, 0. And then this row, multiply by 3, subtract from this one, I will get 0. Then I have -1, -3. Sorry, -1. Oh, I'm adding, not subtracting, sorry. So it's -1 plus 3. This will give me 2. And then 1 plus 6, this will give me 7. And then 0 plus 3, this is 3. And then 1 plus 0, 0 plus 0 is 0. Okay, let me just move this closer. Then here we said row 3 minus row 1, so minus 1 minus negative 1, this is 0. Then 3 minus 1, this is 2. Then 4 minus 2, that is 2. And then 0 minus 1, this is minus 1. Then 0 minus 0, 1 minus 0 is 1. Okay. Then I can make this one here a 1. Just divide everything by 2. And this one here, I can make it a 0 by saying row 3 minus row 2. So second row, I will divide it by 2. And then the third row, I will say row 3 minus row 2. So the first row is not going to change. So I have 1 minus 1 minus 2. I have minus 1, 0, 0. And then the second row, we say we divide it by 2. So it's a 0, 1, 7 over 2, 3 over 2, a half, and 0. And then the third row, we said row 3 minus row 2. So 2 minus 2 will get 0. So there's 0 minus 0 here. 2 minus 2 is 0. Then 2 minus 7, that gives us minus 5. And then minus 1 minus 3 is minus 4. Then 0 minus 1 is minus 1. And then 1 minus 0 is 1. Okay, so here we want to make this a 1, so we will divide this by minus 5. And okay, let's just do that one. So we have 1 minus 1 minus 2. Okay, I think here we could add these 2 rows over here. So if I say row 1 plus row 2, then our work will be faster. Okay, so here it's 1 plus 0, which is 1, minus 1 plus 1, this will give me 0. And then minus 2 plus 7 over 2. This is 3 over 2. And then 3 over 2 plus minus 1. This is half. Then half plus 0 is half. And then 0 plus 0, which is 0. Then the second row, we haven't done anything, so we leave it for now. So it's 0, 1, 7 over 2, 3 over 2, a half, 0. And then the third row, we divide it by minus 5. So we have 0, 0, 1. Then negative 4 divided by negative 5. This is positive 4 over 5. Then -1 divided by -5. This is +1/5. And then 1 divided by -5. This is -1/5. Okay, so now we want to make these ones zeros. So to do that, we can multiply this row here by 3/2 and then subtract it. So we can say this is row 1 minus 3/2 row 3. And then the second one, we say row 2 minus 7/2 row 3. Okay, let me just take this to the other side. Okay, then what we have is 1 minus 0 is 1. 0 minus 0 is 0. 3/2 minus 3/2, this is 0. Then we have a half minus 3/2 times 4/5. Okay, minus 19/20. Yeah. Which is different from what I got first. Didn't type it in correctly. Okay, minus 7/10. Yeah, that's fine. Okay, then again, half minus 3/2 times 1/5. I'm getting 1/5. And then 0 minus 3/2 times -1/5. This is 3/10. Okay, then same thing with the second row. 0 minus 0 is 0. Then 1 minus 0 is 1. Then 7/2 minus 7/2, which is 0. Then 3/2 minus 3/2 minus 7/2 times 4/5. That gives us minus 13/10. And then half minus 7/2 times 1/5, which is minus 1/5. And then 0 minus 7/2 times -1/5. This is 7/10. Okay, and then the last row, we haven't done anything to it, so it remains the same. So this is 0, 0, 1. Then I have 4/5, 1/5, and then minus 1/5 here. Okay. So that is what we've got. So you can see where we started. We had our identity matrix on this side. We performed Gauss elimination, and now we have the identity matrix on this side. So once you have the identity matrix on this side, you stop, and then this matrix on this side, that is your inverse. So A inverse is equal to this matrix here, minus 7 over 10, 1 over 5, 3 over 10, minus 13 over 10, minus 1 over 5, 7 over 10, 4 over 5, 1 over 5, minus 1 over 5. So that is your inverse. So you just read the right part of your augmented matrix. And you can always test to see whether you have the correct answer or not. So the test is you multiply A with A inverse. The answer must be equal to the identity matrix. And when you perform it in the other way, with switching the order, A times A inverse, you should get the identity, and A inverse times A, you should also get the identity. Then you know that your matrix over here is in fact the inverse of the matrix that you started with. So again, you can see what we're doing is not complicated per se. It's just very easy to make a mistake in your calculations, and one mistake with one row operation affects everything that comes after that. So try and be as careful as possible when solving these equations. So we can actually make use of the inverse in order to solve a system of linear equations. So previously we would just use Gauss elimination to work it out, but you can also use the inverse. So sometimes the question would say solve the system of linear equations using the inverse method. And what you have to do in that case is first you work out the inverse like I have done over here. Then you will have an equation of this form. You have A multiplied by, this is equal to Y. Then you multiply by A inverse on both sides. So you have A inverse times A times X is equal to A inverse times Y. Then these two give you the identity. So then you'll have X is equal to A inverse times Y. And then from here, your X, which is the variable matrix, so you have X, Y, Z, then you can compare, because matrices are equal if and only if the corresponding elements are equal. But we'll look at an example of how to solve or work that out. So we have to solve this system of linear equations. We have X plus 3Y plus 3Z is equal to minus 2, X plus 3Y plus 4Z is equal to minus 2. And then we have X plus 4Y plus 3Z. This is equal to minus 3. And now we have to solve for X, Y, and Z using the inverse matrix method. So that means we will have to find our inverse first, then multiply it on both sides, and then compare the two matrices that we have. So first we write this in matrix form. So we take our coefficients of x, y, and z. So I have 1, 3, 3, 1, 3, 4, 1, 4, 3. And then my variable matrix, which is x, y, z. And then this is equal to the solutions -2, -2, -3. So this is my matrix A. This is my matrix X with the variables. And then this is my matrix Y. So you can see I have A times X is equal to Y. So I want X to be alone. What I need to do is multiply by A inverse on both sides. Here I will put A inverse. Then I will have X by itself. So this matrix is gone. Then I'll have this one here isolated, and then I can just read off X is equal to this, Y is equal to that, and Z is equal to that. Okay, so we need the inverse of this matrix. So we're going to use Gauss elimination. So I'm going to write the augmented matrix with the identity on the other side. So doing that, I have 1, 3, 3, 1, 3, 4, 1, 4, 3. And then this side is the identity matrix. Okay, so now that I have this, my goal, remember, is to make the identity matrix here. And if I do my calculations correctly, then whatever I have on this side is the inverse of A. So I start here with saying I want to make a 0 here and there. So this one can just say row 2 minus row 1, and same thing, row 3 minus row 1. Okay, then what I have after that, first row hasn't changed, so it's 1, 3, 3, then 1, 0, 0, then 1 minus 1 is 0, 3 minus 3 is 0, and then 4 minus 3, this is 1, then 0 minus 1, minus 1, and then 1 minus 0, 1 minus 0 is 1, then 0 minus 0 is 0. Then same thing with this last row, 1 minus 1 is 0, and then 4 minus 3 is 1, and 3 minus 3 is 0. Then 0 minus 1 is minus 1. Then 0 minus 0 is 0, and then 1 minus 0 is 1. Then I need to make these two zeros. So we have to first make this one here is 0. I will multiply the second row by 3 and then subtract it. So this is row 1 minus 3 times row 2. Then this will give me 1, 3. 3 minus 3 is 0. And then 1 minus negative 3, this is 4. 0 minus 3 is minus 3, and then 0 minus 0 is 0. Then the second row does not change. Third row also doesn't change. Okay, and then what I do is I want to make this one here a 0, so I multiply this by 3 and then subtract. So row 1 minus 3 times row 3. And then I also want to interchange row 2 and row 3. Now here, because I am solving a system of linear equations, interchanging rows doesn't really affect my answer, because I'm trying to solve for x, y, and z. But with finding the inverse, interchanging the rows, I think, would change the answer if you are just trying to work out the inverse. Here, my goal is to use the inverse to get x, y, and z. So you can see that here I can change this. I can write this one first, then this one, then that one. The order I put them in doesn't matter because it's a system of equations. But when you are given a matrix, let's say this was what I was given, if I interchange rows, I have changed the matrix, and then the inverse I get of that matrix is not necessarily the inverse of the matrix that you started with. So just be careful with that. So if you're just given a matrix and you're not solving for x, y, and z, don't interchange rows. But if it's a system of linear equations, it doesn't matter what order I put these matrices, these linear equations in, so interchanging is fine. Okay, so I'm also going to interchange row 2 and row 3. So what I will have from there is 1 minus 0, which is 1, then 3 minus 3, which is 0, then 0 minus 0, and then 4 minus negative 3, this is 7, then minus 3 minus 0 is minus 3, and then 0 minus 3, minus 3, and then we say this third row will come second, so it's 0, 1, 0, minus 1, 0, 1, and then I have 0, 0, 1, minus 1, 1, 0. Okay, so this inverse that I got here is the inverse of the matrix with the rows interchanged. So if I want to state the inverse, I must switch this row with that one, and then I will say I have this matrix here, let me call it A, which is 1, 3, 3, 1, 4, 3, 1, 3, 4. And then A inverse is the matrix that I have on the other side, which is 4, minus 3, minus 3, minus 1, 0, 1, minus 1, 1, 0. Okay, so this is the inverse of that one, not of this one. I'm sure if you multiply these two, you probably would not get the identity matrix because of the interchanging of rows. So again, if you're solving a system of linear equations, interchanging rows doesn't affect anything. But if I want to work out the inverse of a matrix, because the matrix is specific. You cannot just change rows and columns. You cannot just interchange rows, because you'll now be working out the inverse of that new matrix that you got, not the original one that was asked. So here, selection. Okay, my screen is frozen. Okay, so this is what I had. Say this one is the A, and remember I had A, X is equal to Y. So I had 1, 3, 3, 1, 4, 3, 1, 3, 4 times X, Y, Z. This is equal to minus 2, minus 3, and then minus 2, because I switched these two rows. Okay, then multiply by A inverse on both sides. So I'll have X, Y, Z. This is equal to 7, minus 3, minus 3, minus 1, 0, 1, minus 1, 1, 0. Then we multiply this by minus 2, minus 3, and then minus 2. Okay, and then you need to multiply row with a column. So this gives us 7 times minus 2 plus minus 3 times minus 3 plus minus 3 times minus 2, which is 1. Then minus 1 times minus 2 plus 0 times minus 3 plus 1 times minus 2, which is 0. Getting 0 here. I think I should also switch the variables then, because Z is the one that's 0. You see. So this is 0, and then the last one I have minus 1. And minus 1 times minus 2 plus 1 times minus 3 plus 0. I'm getting minus 1. Let's see if that works. So here I would say X is 1, Y is 0. 1 plus, so I have 1 plus 0 plus 3 times minus 1. Okay, it satisfies the first equation. Then I have 1 plus 4 times minus 1. Okay, that gives me minus 3. 1. So 1 times, so here 1 times 1 plus 3 times minus 1. This gives me minus 2. I think here I would need to interchange x and y, because I know y is minus 1 and z is 0. So what was I saying? You see the last one, 1 plus 3 times plus 4 times, this gives me minus 3. Okay, let me just try multiplying this two matrices together. So we have 1 times 7 plus 3 times minus 3 plus 3 times minus 3. That's 3 times minus 3 plus 3 times minus 3. It's giving me 11 instead of 1. And I write this correctly. 7 minus 3 minus 3 minus 1 0 1 minus 1 1 0. That is correct. Let's go back. That is 1 3 3. Okay, yeah, I see I'm multiplying it wrong. So it's 1 times 7 plus 3 times minus 1. 1 times 7 plus 3 times minus 1 plus 3 times minus 1. Okay, so that will give us 1. And then let me just do this. So I want to check if this is in fact the inverse of that one. Okay. So we multiply row with column, 7 times 1, 3 times this times that. That gives us 1. And then 1 times minus 3 plus 3 times 0 plus 3 times 1. Okay, that gives us 0 here. And then this row, that column, so we have 1 times minus 3 plus 3 times 1 plus 3 times 0. This gives us 0. Then the next one, 1 times minus 1. And then 4 times 0. Okay. 1 times 7. Sorry, 1 times 7. And then 4 times minus 1. And then 3 times minus 1. This gives us 0. And then I have 1 times minus 3 plus 1 times minus 3, then 4 times 0, and then 3 times 1. Okay. Okay, so this also gives me 0. And then 3. Okay, so that's 1. Yeah. Then this times that, that's minus 3 plus 4 times 1 is 4, and then 0. Now this gives me 1. Okay, so this doesn't give me the identity matrix because I would still have to interchange this row and that one. And maybe here I shouldn't interchange these two. Okay, so let's just finish. This is this times that, which is 7 plus minus 3 plus minus 4. This is 0. And then 1 times minus 3. 3 times 0, and then 4 times 1. Okay, this is 1. And then 1 times that is minus 3. 3 times 1 is 3. And then 4 times 0. Okay. So even though I interchanged the rows, let me try it in the other way now, without interchanging the matrix I started with. So if I have 1, 3, 3, 1, 3, 4, 1, 4, 3, and then this is minus 7, minus 3, minus 3, minus 1, 0, 0, minus 1, 1, 0. Okay, so this times that, nothing will change here. So I will still get 1, 0, 0 because the first row and the first column haven't changed. Then this times that. So this times that is 1 times minus 7, which is minus 7. And then I have 3 times minus 1. Then 4 times minus 1. Minus 7, minus 3. Minus 1, minus 1, 0, 0, 1. Okay, these are all negative numbers. I'm trying to see what I did wrong. The matrix says 1, 3, 3, 1, 3, 4, 1, 4, 3. So this should be just 7. Okay, so 1 times 7, 3 times this, and then this times that. So 1 times 7, 3 times that, and then this times that. That will give us 0. Okay, now it's fine. Okay, then 1 times minus 3. This is minus 3. Then 3 times 0 is 0, and then 4 times 1 is 4. So minus 3 is 4. This is 1. Okay, so it's 4. 1 times minus 3. It's minus 3. And then 3 times 1 is 3. And then 4 times 0 is 0. Okay, then 1 times 7. 4 times minus 1. 3 times minus 1. Okay, this is 0. Then like that, 1 times that. This is minus 3. 4 times 0, and then 3, which is 0 here. And then this times that is minus 3. 4 times that's 4, and then 3 times 0, which is 1. Okay, so I think what I was saying was not correct, that even though I've interchanged the rows, means you must interchange the original matrix that we started with, because this is the original matrix that we started with. And even though when I was working out this inverse I interchanged rows, it doesn't affect it being the matrix, the inverse of the matrix. Okay, so what we should do here is not interchange these two. So we have 1, 4, 3, and then the original matrix. It's 1, 3, 4. This is the original one the way it was, and 1, 4, 3. And here I should not interchange these. Just leave it minus 2, minus 2, and minus 3. And then now just multiply row with column. So we have 7 times minus 2 plus minus 3 times minus 2 plus minus 3 times minus 3. This is 1. And then minus 1 times minus 2 plus 0 times minus 2 plus 1 times minus 3. This gives us minus 1. And then minus 1 times minus 2 plus 1 times minus 2 plus 0 times minus 3, which gives us 0. Then from here we can say x is equal to 1, y is equal to minus 1, and then z is equal to 0. And then substitute them back over there. So you'll have 1 minus 3, so it's 1 plus minus 3, the answer is minus 2. 1 plus minus 3, didn't change this one. So it's 1 plus minus 3 plus 0, still minus 2. Then 1 plus minus 4 plus 0 will give you 3 over there. Yeah, okay. So again, or not again, seeing with what we did, even though I interchanged the rows here, it doesn't affect it being the inverse of the original matrix that we started with. So forget about what I was emphasizing. Just go ahead and do the Gauss elimination, and then the matrix you have over here, as long as you have the identity matrix here, what you have there is the inverse of the matrix that you started with. Okay. Whew. Yeah. So I think we can very quickly look at one question from our exercise. So this is exercise 6.2. Start with number 1. We have to determine the inverse of the matrix. So we're given this matrix here. This is 4 minus 3 minus 1. So with a 2 by 2 matrix, we know how to find the inverse. You would first check the determinant, of course. So our determinant is 4 times 1 minus 1 times minus 3. This is equal to 4 minus 3, which is 1, which is not 0, and therefore the inverse exists. Okay, and then now that we know the determinant, we can easily work out the inverse of a 2 by 2 matrix. What we would usually do is you interchange the two elements on the main diagonal. So the 1 will go there, the 4 will go there, and then multiply these two by -1, and then your inverse, the way we would do it, A inverse. This is 1 over your determinant, which is 1. Then you would multiply with this, and then multiply that by -1 and 1, and then your answer would be 1, 3, 1, 4. And now we want to get the same answer just using Gauss elimination. So when we do that, we come up with the augmented matrix. We have 4 minus 1 minus 3, 1. And then we have our identity matrix here. So we want to make this one here a 0. So to do that, what we do is we will say row 2 times 4. Say 4 times row 2 plus row 1. Okay, so I'll multiply this row by 4 and then add it to that one. So the first row doesn't change. I have 4 minus 3, 1, 0. Then minus 1 times 4 is -4 plus 4 is 0. Then 1 times 4 is 4. And then 4 plus -3 is 1. Then 0 times 4 is 0 plus 1 is just 1. Then 1 times 4 is 4 plus 0. This gives me 4. Then I need to make this one here a 0. So to do that, I multiply this row by 3 and then add it to that one. So I will say row 1 plus 3 times row 2. So it's 4 plus 0 minus 3 plus 3 is 0. Then 1 plus 3 is 4. and then 0 plus 12. Then the second row doesn't change with 0, 1, 1, 4. Then this one here has to be a 1, so I can divide everything by 4. So now I have 1, 0, 0, 1, and then I have 1, 3, 1, 4. So my A inverse is equal to 1, 3, 1, 4. Okay, and that is exactly what we said it would be. Oh, okay, so we'll stop here for today. We'll continue tomorrow. Try the rest of the questions in the exercise, questions where you have to find the inverse as well as solving using the inverse of a matrix. So solving with the inverse, or finding the inverse rather, according to the course outline, you will only be restricted to a 3 by 3 matrix, but I see some questions in the textbook where you have 4 by 4. The procedure is exactly the same, just longer. So I think with the test, you'll only get up until 3 by 3 matrix, but even with a 4 by 4, you should be able to do it. Okay, we'll continue tomorrow.